Today we're trying to find the specific heat of a metal.
Right, yep, it's all about specific heat of two different metals today. Cleverly named Metal 1 and Metal 2.
I think I can remember
We
that.
had to dig deep for that. Okay, now there's going to be a little bit of data measurement we have to get through here. One thing we need is the mass of our pieces of metal. So we're going to do that first while they are dry. All right, here is Metal 1. Let me lay it down. Sorry. Metal 1. Okay, there you go. There's the mass of Metal 1.
Yeah, then metal 2 is hiding behind those styrofoam cups, Mr. Hevel. It's not that one.
Oh, yeah, you're right. Tricking me.
Yeah.
Okay, here comes metal number 2. I
Just
don't know why I'm
caught
using
that.
the tongs. I guess I'm thinking about the hot.
Right, yeah. Okay, metal 2. Different metals, as you see. Where there's number 1,
Yes.
and certainly a different metal.
Yep. Okay, so now these things are going to have to be warmed up. The whole idea is we're going to warm the pieces of metal up to some higher temperature than room temperature. Then we'll put them in some cool water, and we'll see what the temperature changes. Kind of like the last lab we did. But we're going to drop them in here, and we're going to want to leave them in there for a couple of minutes, at least, to make sure they've warmed up to whatever this water temperature is.
I
gonna be
wonder
about
how
good.
hot that water is.
Yeah. You know, let me stick my finger in and I'll give you a measurement.
Sounds good.
So they're heating. While they're doing that, let me explain what else we've got going. We've got our styrofoam cups here with our high-tech lid. Okay, we're assuming that all the heat flow that occurs is between the water in the cup and the pieces of metal. Right, we're insulating from the environment. We're assuming there's no heat flow in or out there. We've got some room temperature water that we're going to put into the cup. So let's get that measured out.
The instructions for this say between 75 and 100 milliliters. So we'll just do something in between those two and have you read it.
Oh, should I put my hand?
No, well, that probably is helpful, yeah. There we go.
Okay, there's your...
So there's our volume of room temperature water.
Now, Mr. Moore, do you remember what's the density of water?
Let's see, 1, I think.
Yeah, because ultimately you'll need the mass of the water.
Yeah.
Remember the MCAT equation. That's my big hint to it. Okay, so we're going to add our room temperature water to our high quality styrofoam cups.
Students at Troy are very fortunate to be able to use this equipment.
Only the best. Okay, so we're going to put a thermometer in the water here in a minute. Now, what you have to be careful of, what's confusing is there's a few different temperature changes going on here. All right, the water is going to warm up when we add the warm piece of metal to it. So there's a temperature change for the water in the cup. There's a different temperature change for the pieces of metal. Right, they're going to go from whatever this starting temperature is to the final temperature of the water in here. Right, we're assuming that the pieces of metal and the water in the cup end up at the same final temperature.
Did you just say they don't have the same temperature change, though?
Not the same temperature change, but the same final temperature.
Okay,
Hopefully I said that correctly.
you did.
Yeah, it's confusing because there's two different temperature changes that are going on here. Well, what do you think, Mr. Moore? I'm guessing the pieces of metal are up to...
Look at those pieces of metal in there. Yeah, should we take the temperature of those?
Okay,
Of
now,
that?
do you want to do this? This is going to tip over.
Yeah, I think we can just get that one. That's going to be a constant temperature. So,
Now, I don't want to put it down on the bottom because the bottom of the beaker is probably warmer than the water, I'm guessing.
okay. So I'll go ahead and tell my handy app to collect that data. And what does it come in at? See, we have a rise in temperature. I think the thermometer is still warming
Oh,
up.
that could be.
Can you see it?
And I don't know, maybe we should have it in a ring stand, so, because I don't know, could the temperature vary if you're going up and down?
I wonder.
I'll try to hold it close to the bottom. I'll set it right on top of metal number 2.
Uh-huh. It looks like it's parking right there at 100. That's pretty nice. Because when we use the liquid-filled thermometers, you don't get 100 degrees.
No, you don't.
You might get 97 or whatever, but look at that.
102.
That's right on 100.
Okay, so I can take this thermometer out now.
Yeah.
We know the
That-
starting temperature.
Yep,
of our
we're not
piece
turning
is
that
metal.
down. That's just going to stay at 100 degrees.
So there's your metal start temperature.
Yep.
Okay, now we don't need the balance anymore, right? We got both
Right,
of
yeah.
these. So I'm gonna get this out of the way. All right, so now what I'm gonna try to do is quickly transfer the warm metal into the cool water, but we're gonna wanna see this starting temperature first.
So that's the other thermometer.
Yes.
And
Do you wanna use the same thermometer?
yeah, so ignore now that blue. We're just going to say that because the blue has been taken out, that other thermometer is taken out of the boiling water. This one, though, you remember if we just give that a touch, it'll tell us what the initial temperature of that water is. Looks good. 20.8.
Correct.
But now it changed to 20.9. We're going with 20.9. We still have the thermometer in there.
Okay, so now this will be metal 1. Okay, I'm gonna try to quickly pull it out of the warm water, hot water, and into here. Are we ready, Mr. Bourne?
I'm ready.
I don't want to bring any drips of water.
Quick
with
little
it, though.
shake, yep.
So make sure it's submerged. High-tech lid. Give it a gentle stir. Trying to disperse the heat through the water.
I remember doing a lab like this not long ago. Such a good lab.
It was great.
Sir.
Wonderful experience.
Okay,
What's
what is
going
going
on?
on with the temperature? All right. Well, we need to just slide this thing over and we'll see that, well, there is a temperature change. It started at 20.9. It's now, we'll just stir for a few more seconds. See if it goes up anymore. Well, it went up a little bit. I think that we're good though.
Look at it.
I think 24.1 is the final temperature.
24.1. Okay, so I'm going to dump this water out. We'll reload for metal number 2.
Yeah, we don't want to keep the same water in there, do we, Mr. Hubble?
No, because it's warmed up. Now let's go with our room temperature water, because in theory we're getting hopefully a consistent starting temperature here. So repeat. We'll need to measure out the volume of water used. Somewhere between 75 and 100. I'm just going to dump something in there that's somewhere in that vicinity.
Oh, a different amount of water. Okay, this is good. Do the best you can getting the lowest part of that liquid. Okay?
In our high-tech cups. Okay, do you want to verify?
I don't know if we need to.
It should still be 100 degrees, I would think.
Okay. Well, once again, the thermometer's warming up as it sits in there. There it is. Don't think we want to totally put our students to sleep here, so we'll say that the initial temperature of the metal is 100. In fact, we'll even call it 100.0.
Okay.
I guess we could. We can tell what that temperature was. It was, what, 99.5. We'll go with that, 99.5.
Okay. Sneeze. Excuse me. Okay, here's your
Okay.
temperature water.
Come on. And once again, 20.9.
20.9, okay.
Yep.
All right, it's the same routine. Here comes metal number 2. Okay, it's in.
Okay, we have a temperature increase this time. It's gone up to 25 degrees. Well, let's see if it hasn't changed, then we'll say that that's good. Looks like it has. Final temperature, 25.4. Now, what again is that the final temperature of? 25.4 is the temperature of what exactly?
Right, so that is our final temperature of our water. It's in the cup, and the piece of metal that's in there. They have
Yeah.
the same final temperature. Different temperature changes, same final temperature.
Okay, so we can use this data to determine the specific heat of both those metals.
Yep, I think it's a wrap.
Here we go.